Hello and welcome. Bill Judge with Monkworkz here. We've finally gotten an installation video together, and I hope you enjoy it here because it's a pretty special aircraft. It's the Havilland DH88 Comet. Flew from London to Australia in 1934, and we're going to put two generators in this aircraft because the generators they have are ancient and not very reliable. So let's get into it. So let's take a look at what we're taking out of the airplane here. We got a 10-pound generator, which is good for 17 amps here. And the generator they're putting in weighs about 2.6 pounds all up weight. And the problem is that there's also all of this drive mechanism that came with this generator in order to make it work. And it includes a flexible shaft that comes off the engine and loops down around to the side of the aircraft here. So all of this all together, generator and all the drive mechanism, is 44 pounds. And then there's two engines on this airplane, so we're saving a grand total here of at least 88 pounds by putting in the Monkworkz generator. And you know, that's a significant amount of weight for a plane that only weighs about 2,000 pounds. So and with so many fewer parts, the reliability should be significantly better as well. Okay, before you get into the actual installation on your aircraft, you want to do some planning. And I recommend you start with things that you don't have any control over where they are located to things you got more control over. And so I've got the entire kit here in front of me. I've got the contents, the accessory pack out, and I'll run through all the components that are here and how I think you should do your installation. So usually aircraft only have one vacuum pad. So locate the vacuum pad on your aircraft and put the generator there. Then you'll notice you've got 15 inches of wire to work with here. Sometimes this is enough wire to reach back toward the firewall. Sometimes it isn't. And that's, not a problem because you can mount the regulator in a bunch of different ways, a bunch of different places. A lot of people do mount it on the firewall, and there's nothing wrong with that. But with a lot of aircraft, it's difficult to get to the back side of the firewall. So my recommendation is to mount it on the engine mount using Adele clamps. You can use a tap to tap these out to take an AN3 bolt, use an Adele clamp, and then just use two at the corners. This is 5mm thick, 6061 aluminum, and plenty robust if you're using a bolt as big as an AN3 and Adele clamps on the engine mount. And that lets you find a place that's probably a lot closer to the generator, allowing you to keep these lines at their provided length. If you end up having to extend these wires, you got to deal with the small wires too, and you could be inviting electromagnetic interference issues. So highly recommend you mount the regulator within 15 inches of the generator. Mounting the generator itself, I provide a orange silicone gasket. Fits nicely on the generator like that. There's a locating lip that sits inside the vacuum pad as well. And then torque values here. So a bare minimum of 18 inch-pounds of torque here. And if you leave the torque that low, you're going to want to put some Loctite on there as well. But the order of operations should be put on the washer, put on the lock washer, put on the nut after you put the generator in place with the gasket. Torque it down. Some aircraft, it's hard to get to the lower left nut here. Do your best to get to it. I use a 2-wrench method a lot of times where I reach in with one open-end wrench that straddles the nut that's the right size, and I use another, whatever wrench you've got, to grab the closed end, and I turn the wrench. And obviously that's not using a torque wrench, but what you're looking for is you're looking for this gasket to crush down at least a reasonable amount, but don't over crush it, don't overdo it. Bare minimum of 18 inch-pounds of torque on that. And like I said, if you do leave the torque that low, you're going to want to put some Loctite on it as well. So what's after that? I've got the generator in place. I've got the regulator mounted. I've made the distance reasonable so that I can reach there with these power wires. So I provide crimps, and really the only things that should interface electrically wise with the regulator are the crimps and the pigtail terminals, Pico locks that I provide you. These terminals have the right geometry to sit on the side of the circuit board, not interfere with anything else. And they're also high quality crimps that have both a metal to metal crimp and then a strain relief. You want to make sure when you're doing your crimps, you take advantage of both of those. So crimp the 3 wires. Doesn't matter what order they go in. This is 3-phase AC. the regulator turns into DC as soon as it gets on the regulator board. So it doesn't matter what order they go in, but use a good quality crimper, crimp them on there, and you're done with that. Next up is the output side. So same number 10 crimps. You want to use number 10 wire here coming out, number 10 tefsel for the power and ground connections. Ground, go to a good ground that's in your aircraft. I provide you some 5/16 inch ring terminals that you can use on a ground. If you happen to have a ring terminal, a ground rod that's 5/16. But these terminals, these 5/16, are more relevant for contactors that most people have in their aircraft. For a quick and easy way to install on your aircraft, you can go right to the switched side of your master contactor, or typically, if this is in the back of the aircraft, you'll have a large wire running forward to your starter contactor, and you can grab the unswitched side of your starter contactor with this ring terminal. Before you do that though, you want to make sure you have some kind of circuit protection on this, because the run between the regulator and where you jump to your bus could short to ground and drag down your entire bus. So you want to have some kind of a fuse fairly close by to this, fairly close to before you dump onto your bus. And to remedy that, I've got a blade fuse provided and 2 fast-ons. If you close down the opening a little bit on the fast-ons, you can make yourself a high-quality fuse holder. You'll notice that most of the fuse holders you find out there are not something you would want to put in an aircraft with PVC wiring and whatnot. So this allows you to use good quality crimps, a good quality fuse, put heat shrink around the entire thing, and then this ring terminal that goes on the contactor, you just want a short pigtail between those two, however you want to orient it, and then you can attach to your contactor, attach to your bus. Now, you might have a more complicated electrical system where you want to run the power somewhere else, you want to run it through a relay, you want to go to a critical bus. That's beyond the scope of this installation here, but I provide these in order to speed your installation along. So that's power output on the output side. Next up is control wiring. So we provide a Pico-Lock pigtail here, and pin number 1 here, once this plugs in, if you take pin number 1 and either attach it to pin number 6, which is a ground, or attach it to another ground, that's the command for the regulator to come online. And that's your means for turning the regulator on and off. So highly recommend you take advantage of the pilot-operated switch that I provide as well. It goes behind the firewall, somewhere where the pilot can reach it, turn the generator on and off for testing on the ground, or in the event that you have smoke in the cockpit, electrical fire, and you're trying to kill the source of energy for that fire. I provide very small little crimps that you can use on that control wiring. I don't know what the official crimp tool is for these tiny crimps, but I use my Nypex parallel soft gel pliers because I get a nice parallel crimp and I can very carefully control the amount of force on them. As with any crimp, you're looking for a little bit of flow in the metal, and that will give you a good, reliable connection. And then these don't have any insulation on them, so you got to put heat shrink over top of them once you're done. Same thing for the fuse that you made. If you're doing this fuse holder arrangement, you want to put heat shrink over the entire thing, immobilize it all. Now, we also have to put in some cooling. The Havilland DH88, it decided to use a scoop that had on the side of the cowling, so they had to extend this further, which is perfectly fine. But most aircraft, you've got baffling that's very, very close to the generator and the vacuum pad. So a 3 to 6 inch run from that baffling into the generator, and then whatever amount of distance you need for the regulator here. When you get your kit, some people's reaction is, oh, I need to do something to hold this duct in here. This duct just snaps in to the regulator like that, and then it's not going anywhere. It is attached. And I'll show you how much it takes to pull it out. That was probably 50 pounds of force there they had to use in order to pull that out. So same thing, snaps into the generator. So you put a 3/4 inch hole in your baffling and that will capture the other end of this tube. And if you want to put some RTV around it, that's perfectly fine to seal up the edges, but it's generally a very tight fit and you don't actually need to seal it. So there are a few optional connections as well, and you can take advantage of those. You can read up more about them in the manual, but there are a Hall effect emulation and a shunt emulation. You can interface with a normal EFIS. You got to calibrate them and tell the EFIS what exactly or how exactly to interpret the electrical signals coming from it. And also, once you actually get up and running, you want to do some testing to figure out if you've done the installation right. Even before you start the engine, when power runs from your bus over to the regulator, you will get blink codes on here. There's a little LED here that says blink, and I took up some of this very valuable real estate here where it says blinks, 3 for disabled, 4 for enabled. So turn on your master, flip the enable on, go around and look at it, and you'll hopefully see 4 blinks, just repeating over and over again. 4 blinks, pause, 4 blinks, pause. And that's it telling you that I've got all the connections I need. You know, start up your engine and let's see if the generator actually works. Now, there's a caveat with this that LED doesn't come for free. It's getting energy from your battery. So if you've got a system where you're connecting the power from this directly to your battery, it will drag down your battery over time. So do not connect directly to your battery. You need some means to disconnect it. Some folks have used cube relays. There's been other arrangements, but just let you know that you do not want to connect this thing directly to a battery full time because it will drag the battery down while you have the airplane parked. That is pretty much the extent of the installation here. For the Havilland DH88, we'll run through that they're using pin 2 here. Pin 2 is another optional connection that gives you the ability to run a status LED or a status widget on your EFIS. So it will illuminate an LED when your generator is active and trying to put out power. If the generator is active trying to put out power but is being dragged down by the load that's being presented to it, it will flash on and off, 1 second on, 1 second off. That's the regulator telling you I'm trying, I'm not able to keep up. So you may want to load shed, but perhaps you're just taxiing out at low RPM and it can't keep up because it's trying to charge the battery up after a start. So just an indicator, it's nice to take advantage of. And you know, like I said, you can use an LED to connect to it, where you connect to your bus, series resistor, LED, and then you go to pin 2 here, and pin 2 becomes a ground when the regulator is active, and that will turn that LED on and off. You can actually reverse the logic too by connecting it slightly differently. Contact me offline if you want to know how to do that. And that was done in the de Havilland DH88 for each generator, so they've got a left and a right LED that we'll show you later on. That is pretty much the entire installation. So let's run through some of the things, some of the nuances of the wiring that I'll show you in the, when we're actually doing the installation on the airplane. But let's get into that. All right, so probably the most critical part for reliability on the generator install is that when you're putting in the Pico lock connectors, you want to make sure that you have a decent amount of maintenance loop, a decent amount of extra wire with you, and then you put a preload that is a load against the connector with the installation. So I've got the power wires here that I'm going to wire everything against here, and I'm going to use the strength of those power wires to end up immobilizing the Pico lock connector here. So I'm going to slide this back here, Pico lock connector, I line it up really well, squeeze it into place, and now I'm able to grab all these wires together, and then I'm going to zip tie them to here, and that's going to put pressure against the connector. And then if you do that, you're never going to have any issues with reliability of these connectors. I think that's the one problem that people have on these installs is getting these connectors to be reliable. And by and large, there's no issues with them. And if you do this, you're going to have no issues at all. So I'm going to do that on both sides here. Pressure against the connector, zip tie it together, and that's going to give you a good, long-lasting, reliable install. All right, so we're going to do a quick walkthrough of what the installation looks like on the DH88 here. So we've got the regulator already mounted on the firewall here. As I mentioned, it's critical that you get the maintenance loops in place and you secure the small Pico lock connector wires to the larger power wires. So I've got that done on both sides of the regulator here. They already mounted the regulator on the firewall here. You have 2 cooling ducts that come out of the regulator and the generator. And those are running around to the other side of this engine here, where they already have a cowling inlet for cooling air. And that's the basic install from a physical perspective. There's a vacuum pad on here where they've torqued down the bolts to whatever the manufacturer specification is here. They've also used my orange gasket because we wanted to stop the heat from transitioning between the engine case and the generator itself. So that's the basics of the mechanical installation. And the electrical installation is pretty much per the drawings, positive and negative on the one side of the regulator, and then you've got your control wires, your enable, and also we're just using the status pin here. And then you got 3 power wires that come out of the generator, along with a thermistor. We've shortened the cables on the generator just because that's what this particular installation called for. And then we use the extra wires doubled over here and zip tied in place. If you want good reliability for your electrical installations, immobilization is key. So I've got plenty of zip ties here holding the wires in place. That pretty much is the gist of the installation underneath the cowling here. So now we're in the DH88 Grosvenor House Comet cockpit, and I'm just going to go through the installation in here, which I didn't have anything to do with. The crew here did it, but they got LEDs left and right here that indicate when the generator is on or whether or not it's having issues. Highly recommend you take advantage of this feature, whether you're running into your EFIS or you put LEDs in. Either way works, and there's a way to reverse the logic on this so that they come on when the generator's on or they go off when the generator's on. Either way, they can be wired up, and there's instructions in the manual on how to do that. And then also they've got switches, which are hard to see, but they're down here on the left. Highly recommend you take advantage of the enable feature on the generator so that you have a means to shut off the generator when potentially have an electric fire or just for testing in flight. So that's pretty much it for the cockpit installation. Fairly simple aircraft here in that they're day VFR only. So just indicators on the panel to tell you when the generator is on and whether or not it's having issues. Okay, I'm going to run through all of the connections that are required being added to the regulator, starting from no connections at all up to the generator functioning here. So what I've got is just a regulator sitting there, nothing's connected to it. So I'm going to come in and I've got 12 volts here on these 2 terminals on my test setup. I'm going to add those to the output side. A little spark there because the capacitors on the output side take quite a bit of current. And now you'll notice the blink LED, which is right here, is blinking once. So we get one flash, and that's the regulator telling us like, yeah, I'm on and I'm functioning, but I don't see my input thermistor from the generator. So I'm going to come in, I'm going to connect the input thermistor here, and that will clear the single blink, and we should get a 3 blink after this. So what do we see? 1, 2, 3, 1, 2, 3. Great. So now everything is working except I'm not enabled. And I got my enable switch on here, but I don't actually have my enable connected. So let's leave the enable switch on and we will connect this up. All right. Now a couple things happened here. I've got the enable on, got a 4 blink now. And I also have 12 volts here because I'm measuring 12 volts off of the shunt here. I'm using this voltmeter to look at the shunt in order to get the output voltage. And I still have 0 volts on my proportional current pin 5. So what I'm going to do is I'm going to kill the power supply that's sending 12 volts to the regulator here. And now just a dummy load is going to be connected to it. The dummy load has 0 load right now. You can just see the voltage float down to 0 on the output side. And we're going to go ahead and turn the generator on. It's going to get kind of loud. Actually had to connect the generator first. So if you didn't have the generator connected, obviously you're not going to get any power out. But all the blink codes will still check out. You'll still get a 4 blink here. That's why if you get to the point where you've got a 4 blink, but you're still not getting power out, you should check these output fuses and check your terminals. Make sure the crimps are really good. Each one of these terminals needs to be observed going up and down in voltage in order for the regulator to be satisfied that the generator is connected. So that's a safety feature because it will burn up the generator if we pull power out of it without pulling it from all 3 leads equally. So now I'm connecting the generator. Generator's connected. We still have 4 blinks. Actually, we don't have any blinks because we don't have any power going to it. So let's turn the generator on. Pretty quickly we get our 4 blinks. It's going to go through its self-test and boom, we're at 14.65 volts and we have no load. So I'm going to start turning on load. That's about 18 amps that's being pulled out of it now, and you see the proportional current is showing 1.5, 1.6 volts. We'll add some more load. We're getting up to over 20 amps here, maybe 25 amps. And we're going to add even more load. And what's going to happen is the output voltage is going to get dragged down. We're right at the limit now, 2.7 volts, that's the current limit. So any additional load is just going to drag the voltage down. We still stay at about 2.7 volts on the current output, but now the voltage is lower. And here I've got the status LED hooked up so that it's showing you it's flashing on and off, letting you know, hey, I'm trying, but I'm not able to keep up with the current demand. I'm going to take away some of the load. And now it goes back down to 0. I've taken away the load completely. I'm going to shut off the generator. And that's a completely reasonable ground test there. You know, on the ground, go over, look and see that you've got your blink codes working the way you expect them to. Make sure the generator leads are connected. And then go in, start up the engine, and see if you get the indications you're expecting in the cockpit, whether it's just the status, or if you've got a means to measure voltage, you should see the voltage come up. And if you've got a means to measure current, you should see the current come online as well. So that's how I would test out the generator when you first start it up. You know, check the blink codes, make sure your connections are good on the input side. You know, voltage and current are what you're looking for in the cockpit. And if you're taking advantage of the status LED, you should see the status LED as well. Okay, at this point, if all the ground checks look good, it's time to take the airplane out for a ground run. And the ground checks should be connections from the generator to the regulator look good. You've got the thermistor plugged in. You've got power and ground running to the regulator as well. When you switch on the master, you see 3 blinks without the enable on, 4 blinks when the enable's on. If all that checks out well, you've got the cooling ducts installed, generator's obviously installed on the engine as well. It's time to go outside and do a ground run. So take your trusty and numerous ground crew, get them to help haul the airplane out, put it in a good spot to do a run up, chock the wheels, pull the prop through a few times, then ask them to spin the prop. Airplane's gonna belch out a huge, majestic cloud of smoke. It's gonna shake off the long winter cold like a bear waking up from hibernation. Let it warm up a little bit, get your oil temps up to where you're comfortable with them, and then do a run up to the minimum RPM to get the self-test to kick in. So Lycoming engines, it's going to be 1200 RPM, a little bit lower on a Continental engine, and on the 28 volt installation, it's going to be quite a bit higher. On this particular engine, on the Gipsy Queen engines, they're running 1-to-1, so I had to get up to about 1800 RPM in order to see the self-test commit and pass. After that, you should probably see the flashing LED if you've got the LED hooked up. You should see voltage rise above your battery voltage, and you should see current coming out of the generator. And then you can kick it up to full RPM, then it's going to kick into 2-channel mode. It's going to have double the current output. And in this particular case, we've got 2 engines, so we've got 2 generators to check out. Did the check on the left and the right. So initially you see the LED flash, and then once the battery gets topped up, you get full voltage and the LED stays on steady. If you have it wired for logic when it's on with the generator being on. So that's really it. At this point, the generator should be a good, reliable power source for you for many flying hours, many happy flying hours. And I would be remiss if I did not mention how grateful I was for Shuttleworth allowing me to come along for this incredible adventure. It's an incredible honor for an organization like them that's got such special airplanes and is so deliberative and cautious about what they do with their airplanes and how they run their airplanes and what equipment they put in their airplanes. So I was very grateful they selected my product. They did pay for it. I paid for the trip over there to help them with the installation. I volunteered to do that because I thought it'd be a spectacular experience, and it absolutely was. Everybody from the chief engineer that I interacted with on down to mechanics that I worked with were all spectacular, and it was a fantastic experience. If you ever have a chance to go to Shuttleworth, just outside of London, I highly recommend it. They've got some of the most amazing aircraft you've ever seen. They've got the oldest airworthy aircraft in the world. They've got a whole myriad of evolutions of warbirds, and they've got pleasure craft and anything you can imagine, all fantastically maintained and restored, and they actually fly them, which is spectacular. These airplanes actually fly. So it's not just a standard museum. This is a real flying museum. And so it was a real pleasure for me to go and see them work and actually work with them and all the incredible things they have to do to keep these very unusual aircraft flying. So big thanks to them, and big thanks to you for watching. I hope you learned something out of this and would help you do your own install. If you got any questions about how to do your installation, please feel free to call me, email me, and we'll get your questions answered. Thanks so much for watching, and take care.